Here we go. Chapter 7, I was asking you guys to do the best you can to fill in these problems. Now, which are the two that I already solved for you? The first two. But how did I do it? Remember how we've been writing in a colored pen with all these final review things to remember?
Yeah.
What did I do in number 1? Can anyone see what happened? Jeremy, I didn't put you back there to sleep. Can you move over to the seat you were in yesterday? And then you sit up. Oh, you were? I'm sorry. I meant for you to sit in that seat right over there. That one back there is a little uncomfortable and it's a little bit squished. Didn't mean for you to feel totally ostracized. Okay, so what happened in number 1? What did I do?
Oh, that's all.
What did I factor out though?
5x.
Yeah, but why? Who is he? What is he? How can we tell us something to like study, to remember, to think? Yeah, we looked for what was in common, aka the GCF. Is that good? So what was in common between 5x squared and 20x? A 5 and an x. You see it? So I pulled it out, but what did I do? You might want to write yourself a note to remind you. When I pulled it out, how did I know there was an x and a minus and a 4 left?
Because it's a minus 20.
Because it had a minus 20 and I had to divide. So remember, when you pull out a GCF, you pull it out by division, right? And just for a few of you guys, we were doing that thing where we wrote the 5x on the outside and we were actually dividing. A few of you get confused with this. You don't quite know how to divide or you're not super great at it. But an x over x does go away, but a 20 over 5 is a 4. The minus remains because we didn't pull out a minus. He's still there. And then the 5's reduce and an x squared over x. Just a few of you, we've had to talk about how x squared is x times x to remind you as to why there's an x left. I'm just reminding you. Just a few of you have had to show you that before as to why only one x remains. What did I do here though? Yeah, I did the factoring with the x method, right? And where did this little negative 8 come from? The last, but technically, isn't it times the first?
Yes.
So negative 8 times 1, perfect. And then this 2 came from the middle term, right? And just for a few of you that need to remember, we multiply when we go up, right? We had to find two numbers that multiply to be negative 8. And what do we do when we go down?
Times.
Oh, multiplying is coming up. So 4 times negative 2 is negative 8. And then 4 minus 2 is, technically we add, but if we add a negative, it looks like subtraction. So we're trying to find two numbers that multiply to be negative 8 and add to be 2. Remember that? Mm-hmm. Now, what did I not show yesterday with this problem? Did I show a table?
No.
Now, technically with factoring, there is a shortcut. Whenever there's a 1 in front, you technically are ready to go straight to your answer. But I never really showed you that shortcut, never really taught you, never really told you. Because it's a dangerous shortcut, because as soon as you get down here where there's not a 1 in front, it doesn't work. And some of you actually figured out the shortcut and accidentally used it when you weren't supposed to, and it messed you up. But coming back to this one, if we were to make the table, it would have worked out perfectly, because what always goes, whether it's a complicated one or whether it's a simpler one, what always goes in this left-hand box of a table?
The first letter.
Good, the first one, so x squared. Down here, the first one would be 2x squared when I go to make my table. What always goes in this last box? The last term. So that's a negative 8 and negative 3. The table doesn't change whenever, or if I should say, there's ever a leading coefficient of anything other than 1. I still set up my table the exact same way as for a simpler one. I plug in here from my little middle terms that I found a 4x and a negative 2x. A few of you guys make that mistake from time to time. You forget to put your variables in there. But then, how do I come out of the table for those of you guys that use the table? I'm looking for what's in common. So what's in, yeah, like GCF, the greatest common. What's in common?
2x.
Oh, not coming this way.
2x.
No, this is x squared. X squared.
X.
So actually just an x, because the 2 would have had to have been in front, Andrew, but I see what you were seeing. But there's only a 1 in front. So just a 1 and an x. What's in common here, though? A negative 2. Good. We always pull out that last sign. What's in common here?
X.
An x. And what's in common here?
4.
Do you see where my x plus 4 and my x minus 2
Wait, why
came from?
is the x squared in the first box? Why is it x?
Thank you. It is x squared, I just wrote it, I had to squish it, and so the squared didn't get up very high.
Oh.
But it is x squared, Casey, you're right. My x squared ended up looking a little bit more like x squared, so that just seems funny. Yeah, sorry. I would erase it, but then the whole thing would go away and it'd be a mess. But down here, what did I fill in? Wait. What changed for this guy? I mean, the numbers changed, yeah, but what's the big thing that changed that kind of threw everything for a loop and messed it up a little bit?
Oh, there's a number in front of the
There's a 2 in front. So what did I put here and why?
Because you're multiplying.
I'm multiplying the first times the last. Okay, pause. You need to write yourself a note. You guys are listening to me, which is good. It's on the video, which is good. But you need to write yourself a note. Multiply the first times the last. Okay, we got this. We're multiplying to be -6. We're adding to be 1. Remember, 6 is kind of an easy number, so most of you might be okay. But if you needed to, you could just say, hey, 1 times 6, 2 times 3. We have those little tricks about remembering signs, etc. Like, whenever the sign is negative, we know that the signs are going to be opposite, so 1 positive, 1 negative. And the bigger number always has this middle term sign. So we can say down here, opposite signs, the bigger is positive, so I can come and say the bigger is positive, so the smaller is negative. I can put little negatives by the smaller numbers. 6 minus 1, nope. 3 minus 2, yes. I can find my right factor and then fill in my x method. I come over here. I use my table, and I pull out what's in common. Follow my finger, guys. Follow the row. What's in common? X. Good. What's in common?
-1.
Yeah, right? Because 2 and 3 don't share any numbers. There aren't x's, just a -1. Good. What's in common here, though?
2.
A 2 and an x. And what's in common here?
3.
Look at you guys rocking the factor. You just have to go step by step, and you'll be okay. Step by step, and you'll be okay. 2x plus 3 times x minus 1. How can you check any factoring problem? Multiply. And if I multiply, it should go here, and it should go right back there, and you're right. If I multiply, it should go here, and it should go here, and I should be right. You can always double check a factoring problem. Okay, but what's different when the directions say solve?
It's equal to 0.
Good, but what's equal to 0?
Everything.
Everything. So I say that, and that, and that, and that, and that, and that, and that. No. Wait, Trey. That's what a lot of people accidentally did, though. I can't just say you're 0, you're 0, you're 0, you're 0, you're 0. Oh, that can't be 0. Okay, I only am allowed to set equal to 0 factors, aka guys in parentheses. So I need to find parentheses, make them equal to 0, and then solve. Now, does this guy already have guys with parentheses?
Mm-hmm.
He's a yes, and I can make him real quick because it's a times. So he is totally ready for Moses to take and go split the Red Sea. Well, God through Moses. Some of you do mental math and it works. Some of you do mental math and you make mistakes. Be careful. Do your algebra. And as you do your algebra, you would get x equals 0. 0 divided by anything is 0. But this one, wouldn't you subtract 1 from both sides? And then wouldn't you have 2x equals -1 and divide by 2? So x equals -1/2 is your other one. Some of you, you can do the mental math to get there. Some of you just need to go step by step by step, and you'll be fine. But what's wrong with him? There's an exponent and. Do you see any parentheses?
No.
Oh, but what does factoring do? Makes parentheses. So let's go factoring this guy. It looks an awful lot like that guy, but it's a little different for one particular reason. What's in common? GCF.
5.
5 and
5x.
x. What's left when I divide the 5 and the x?
X squared minus 4.
Joseph, just nudge Max for a second. He's struggling to say. It's an x what? X to the power of? It's all right. X to the power of 2 minus
4.
Does anybody know why I changed the problem? I made it from an x squared to an x cubed. Yeah, Kayla, what do you see?
Oh, because you subtracted the 1 x when you divided by 5x.
Mm-hmm.
And 3.
I wanted this, so I did subtract because those exponent properties say when I divide I have to subtract and see what's left.
Mm-hmm.
But doesn't this look familiar?
Mm-hmm.
A squared minus b squared? Is this a special factoring problem? Some of you might want to write down a quick little hint or a quick little clue. When I have an a squared minus b squared, I can always factor it to be a plus b times a minus b. Just a few of you guys are great at that shortcut. So Isaiah, rock it for us, okay? Let's go ahead and factor this dude down. What's he going to become?
X plus 2, then X minus 2.
Good. So I have my x plus 2 and my x minus 2 with my 5x out in front. For those of you that are the x method people, you could also, or maybe another way of doing this is you could make your x, but when you go to put in your -4, you would put in a 0 because your b is missing. And from chapter 8, now you guys know what I mean by b is missing because your middle term, ax squared plus bx plus c is missing. But you could also do the x method with a 0. Either way, you'll get these factors, and what do we do as soon as, aha, now it's legal. So Trey, remember, you said set everyone equal to 0, and you were right, except we had to get parentheses first. So now that well, any multiplying, I can make a parenthesis. How many different answers am I going to have?
3.
You see it? And some of you can do mental math pretty quick. You would get 0 after dividing. You would get -2 after subtracting, and you would get +2 after adding. Good, good, good? Okay. But what did I do with this guy compared to that example? This guy I changed just a little bit so we would have this special factoring to review, but what about this dude? I kept him the same. So what can I do? Because of the work that we did right over there, what do I know that this guy's factors after this work are? 2x
plus 3
and
x minus 1.
so I would have had to have done that work. I'm just going to steal the same problem. We would have had to factor, and as soon as we have our factors, Moses time. He's ready to split. Now, what would you do? Does anybody know an answer right now? X equals? 1. Good. But do you know this one too? Levi's saying it, and he's right, but would you get it right? Or do you need to show your work step by step? The final answer is?
A half, 1/2.
Oh, not a half.
Negative
It is a
1.
fraction. It is a negative, but not 1/2. Levi, what is it? -3/2. If your brain didn't go there, careful. You're going to be staring at multiple choice answers on Monday during the final exam, and you're going to probably see like a 1/2 and be like, ha ha, and be wrong. Just take your time. This is a basic 2-step equation. Subtract your 3 and make sure you get it right, okay? 2x equals -3. You guys know how to do this. Divide by 2, which will take that guy away. Divide by 2. There he is. Multiple choice is going to be really easy just to pick an answer and to give up. Or to be like, bah, this is easy. Careful. Your brain sometimes makes little mistakes when it doesn't go step by step, okay? Okay.
Yeah.
If calculus kids can make addition, subtraction, multiplication mistakes after all the math they've done, so can we in algebra. Okay? Just be careful. Go step by step. Now that, guys, was chapter 7. What haven't we reviewed? Chapter 8. And so we're going to go talk about the chapter 7 practice test. You guys can have or should have your homework where you showed the work to, what was it, 1 and 2, 4 and 5, 7 and 12, or 7 through 12. Before we go to chapter 8, let's go peek at this. That was homework last night. Remember, not the entire thing, but part of it. And you guys were already able to grade and see what the correct answers, A's and B's and C's, were. My question is, where did you get stuck, and were there any ones that you couldn't figure out why the right answer was what they said it was? So open up your work. That's what I'm going to walk around and grade in just a second. We have 2 homeworks. Number 42, which was that Chapter 6 review. Number 43, which was you guys doing the practice test and just showing your work, like I mentioned yesterday. But any places where you got one wrong and you didn't know why? Yeah, which one we got? Number 12. So that's the very end. Are there any questions earlier? Is there any place you got stuck earlier besides number 12? Check.
11.
Number 11. Anything earlier? 10. Anything earlier?
All of them.
1. I have 1, 10, 11, and 12. Anything else you want to see?
20.
20? Oh, because you were looking. Okay, cool. So number 1. This is one of those basic operations ones. If you're looking at your final review, this is one of the basic operations ones. And our hints were distribute away the parentheses. Get rid of the parentheses by distributing, and then combine. So guys, what's in front of each of these parentheses? Just because they happen to be the same. Sometimes they're different, but a positive 1. So when you multiply anything by a positive 1, what happens? 5 times a positive 1. Negative 11 times a positive 1. They stay the same. So I'm allowed to, after distributing by a positive 1, which, Kayla, just a heads up, sometimes it changes. Just this time, we're lucky. Everything's going to stay the same. So negative 7r squared s minus 8rs. After we get rid of these parentheses, the name of the game is combine like terms. I know, it's gross. They're nasty, right? Someone help Caleb out. It's a struggle. Is there anybody alike with r squared s?
Yes.
Oh yeah. Combine like terms. What's negative 7? Oh, some of you have been negatives and the
Negative
positives
10
get messy. Negative 7 minus 3. You can always do it in your calculator. I'm allowing you to have it. It's negative 10. So I have negative 10 r squared s. Okay. Who's next? I just go in order. Negative 8rs.
Negative.
What is there when there's nothing in front and understood? 1.
Negative 9.
Yeah, we have 3. So negative 8 minus 1 is negative 9. I know, careful.
Negative 13.
Negative 8 and then go another negative 1. You're getting farther away on the number line. Negative 9. Or you can think of every subtraction as adding the opposite. Every subtraction is adding a negative. So this is also adding a negative. So I have negative 8 plus negative 1, negative 9 plus negative 4. There you go. See it? And then, what else do we have? That's 10, 10, 10, 10.
Plus
Oh.
10. Oh, plus 4.
That's a 1 cent. My guess was D. Cool. Andrew.
Wait, why did you add negative 4rs?
Because subtraction on, just quick, I know I didn't teach you this back in the day, but somebody did. So negative numbers are to the left of 0, right? Like negative, what were we at? Negative 8. And subtraction says instead of adding, which is to the right, I go left. So one way is to think of minus 1 as going left 1, which would get me at a negative 9. That's one way of thinking about it. But another way of thinking about it, because a lot of people, when they see lots of negatives, especially once you start multiplying and a negative times a negative is a positive, it's easier for us to think of the word subtraction, which is also the subtraction sign. It literally means adding the opposite. So when I had a negative 8 minus 1 minus 4, what that means is negative, now there were r's and s's, but what that means is adding a negative 1. Subtraction is adding the opposite, and then adding a negative 4. So I was using what I know subtraction to mean in order to kind of try to simplify what's really going on. But you can also think of that going left 1 and then left 4. I'm ending at negative 13, which is why a lot of people accidentally go this way. Does that make sense, Kim? Okay, we're going to number 10. 10, 11, and 12. If you guys notice, it was towards the end, and Isaiah has a question on number 20, which is really towards the end. That you guys didn't have to do, but he was working on it as he was practicing. Do you see what word this is?
Doctor.
I totally knew you were going to have questions, and I love that you asked, because that means you got a little stuck. But pause. I know, I shouldn't be telling you this, but I am. If it's possible to work backwards on a multiple choice question, you technically could. If you got stuck on this, or this, or this, well, this one's, it's not a multiple choice, but either of these. My question is, do you know how to multiply? If so, couldn't you have multiplied every single one and found the one that worked? I'm just saying, it's going to take more time, but if you get stuck on a problem, you could work backwards. Now, to be honest, I don't feel like multiplying 4 of these, so I'm not going to. Although, I guess I could technically look at them. Some of you might be able to multiply in your head a little bit and be like, A is the right answer. But But just a quick reminder of why A is the right answer. Besides just multiply and saying, yay, it works, is that we could throw the 80 and the 18 in my x. 80 is nasty because he's big, but that doesn't mean that he's impossible, especially with a calculator, because you could start dividing him and saying, hey, 1 times, 2 times, 3 times, no, 4 times, 5 times. You could be dividing in your calculator to figure out how to fill this in. 80 divided by 5 would be 16. And then I have 6 doesn't go in, 7, 8 goes in. I'm in a circle because this positive meant they're going to be the same sign. The same sign is going to be, I knew it was adding, so 81, 42, 24, 21, 18, I got it. Since there's that 1 in front, it's technically a shortcut to go straight to the answer. It only works when there's a 1 in front. You could have also thrown your table in real fast with your x squared, your 80, your 10x, and your 8x. And what would have come out? The 10 and the x and the 8. Booyah. Letter 8. Letter A. Don't remember who asked that one, number 10, but does that answer your question okay? Number 11 got 1 step harder, yeah? Because number 11 says there's a number in front. But wait, we just did one of those, so come on, rock it.
Oh, you could do the box.
I can get to the box. The box says I have a 2x squared and I have a 15. I need to figure out who multiplies to be, what's that number I'm looking for?
Oh, 15 times.
30. Yeah, I'm looking for 30.
So
We good?
That goes to that.
Yeah. Be kind of quick though, I want to get you number 20.
Okay.
We're looking for 30. So 30, 1 and 30, 2 and 15, 3 and 10. Do any of those look helpful to get that 13 that I really, really want? 1 and 30. 2 and 15. Oh, 2 and 15.
yeah.
Gorgeous, right? Except doesn't one of them need to be a negative
Yeah,
for that to work?
The 2.
But does that work?
Oh, make,
No.
oh.
So wait, that was so good, but it's not. It wasn't 1 and 30. It's not 2 and 15. Oh, 3 and 10. Is there another way of getting there? Some numbers have multiple options, but only one of them, sorry, it's a 13. Only one of them is right. 3 plus 10 gives me that positive 13, and 3 times 10 gives me that positive 30. Got him. I have my 3x and my 10x, and I say, who's in common?
5.
Oh, we can go, yeah, 5 is this way, right?
Yeah.
And then, what's this way? Just an x. Good. And this way?
2
Rocking it. This way? So my final answer is the one that has 2x plus 3 and x plus 5. Oh my goodness, they were both A. Don't just choose A on your final. That's a bad idea. These just happen to both be A. But number 12 is a bummer. Someone had a question on that too because there's no multiple choice. Now remember, your final, all the multiple choice is going to be together, all straight in a row. But then after the multiple choice where you fill in a Scantron with them, don't give up, don't give up. You have to work on them one by one. If you get stuck on one, just move on, start. After that multiple choice, then is going to be a long answer section. So this is still helpful, but it's not going to be like all intermixed. That's weird. That's kind of, But does anybody notice what that guy looks like? Is it a trinomial? A binomial? Is it a trinomial? A binomial? If I can handle that in the sweatshirt. That's not. Take it off.
What?
Take it off.
I don't even know how to.
5, 4, 3, 2. Thank you.
You're welcome.
So number 12. Is it a trinomial? No, so I can't go straight to the x. I mean, I could, but what would I put in that little middle?
36.
0.
Oh, you're
Right, it's missing it.
7.
Those of you that know that a squared minus b squared trick, this is so easy. If you know the trick, it's so easy. If you don't, it's so hard. If you know the trick. Now, Isaiah's gone. He's not able to help us, but I know some of you know the trick too. Armando.
Isn't the trick with the calculator?
Yes, in that you can multiply the 36 and the 16, but that's actually for over here. Because if you did it the long way, I'm not going to go straight to the answer yet. Have you done it, Armando? What's 36 times 16?
You gotta get my calculator.
Oh, thanks, bud. What do you got?
576.
Some of you would get so overwhelmed with this negative 576. You're like, oh my goodness. But the nice thing is, whenever you have this guy, you're always looking for the square root, the radical of, which is the button in your calculator if you know how to use a calculator. Did we talk yesterday about how, for the final, yes, you can borrow one of my calculators, but number one, we might run out because everyone's going to be trying to get one. And number two, you won't be used to whatever random one you get. You might get a good one, you might get a weird one. It's important if you have a calculator to bring the one you're used to because you should know where the square root button is. Did you find it, Armando? What is the square root of 576?
I can't do that on my phone.
Oh, try turning it sideways. There are lots more options. Does anybody have a calculator close? Or know how to find the square root button? Ah, we're in math class and you don't have it? The square root of 576, did you find it? It's that little radical button which, oh, there he is. See, I had to learn where this one was. I think it's 24. So my X people, my X method people, you would want to put a positive 24 and a negative 24, and then you would go to your box. But the weird thing is you would throw in your, remember, you throw in from there the first term, the last term, and then you would throw in your 24x and your negative 24x. It might look funny, but you'll get it right. But my people that know the shortcut, maybe you could have gone straight to the answer. The answer being what's in common, a 6 and a 6. And a 4x and a negative 4x. Do you see how we just square rooted 36? Plus the square root of 16 and x squared. And then the square root of 36 minus the square root of 16x squared. If you know the shortcut, maybe you can go straight here. If not, the x works. It's just a little tricky. But my hint is, Armando said the calculator shortcut. The calculator shortcut, if you get this huge number, but it looks like this special product, you can always use that square root button. And it will tell you, hey, same number. One positive, one negative, and we got it. Perfect timing, Isaiah. I'm ready for number 20. The rest of you guys, was there a place I lost you in this one at some point? That special product has a special way of getting straight to an answer. We can also use the X method. Oh, P.S. I'm recording. You can always watch this later, too. Adrian, what's up, bud?
That's the answer, number 12.
Yep. 6 plus 4x or 6 minus 4x. There are different ways of writing it. So they might have written a different way. They might have even pulled out like a GCF, because if you guys notice, these are both even. So maybe we could have pulled out like a 2 or something. But this is a good method. Oh, we could have pulled out a 4. We would have gotten 9 minus 4x squared. But this is one way of writing the answer. Number 20. And then let's go talk about the formulas that will be important to put on your half sheet for chapter 8. Number 20 says, how many binomials? Now don't worry, this is probably a bit more advanced than the final's going to be. But look at those numbers there. Mammoth. How many binomials can this guy be factored into when it is factored completely? They're telling us that 6,561 is 3 raised to a power, aka this guy can go down to so many 3s. This guy can go down to so many 2s. Isaiah, let me show you just this real quick. If I was to think difference of squares because of this minus, I would pull this guy down to be a y to the 8th times a y to the 8th, thinking about like exponent properties. Does that make sense? And anytime I end up with one of these guys with a plus, there's going to be a number in front. But this guy gets established, gets stuck, because he no longer is in that a squared minus b squared pattern that's legal to factor. He's actually illegal to factor because of that plus. But what I see is a guy over here who's legal to factor. So then actually I could break this guy down, and then this guy's stuck out here, that plus y to the 8th. The numbers are huge, so I'm just kind of showing you the idea because it just says how many. I could make this a y to the 4th and a y to the 4th. But now he's stuck and he's stuck. But he's not. See it?
And y2.
And then I'm going to have a y squared with a y squared. But the plus is going to get stuck. That guy's not. At the end of the day, I'm going to have that stuck y to the 8th, that stuck y to the 4th, that stuck y to the squared. But then that y squared is going to go down to, now I have to go back and get all my numbers. It'll take a little bit of time. But I'm doing that whole square, so I would square root 256 and square root 6,561 and get all my numbers. Then I would square root whatever's left. I would keep on getting my numbers. But I would have 1, 2, 3, 4, 5. Is that cool? Yeah. But those of you guys, like without the shortcut rule, if you don't know the a squared minus b squared, this, which is why it's not in the final, because I didn't make all of you guys use the shortcut method when we learned that one. But yeah, good question. That was a fun one. Okay, guys, that's chapter 7. Why did we spend so much time? Oh, didn't we take like 2 different tests on that too? Right? And we had to retest, then we did test corrections in the middle. Is factoring important?
Yes.
Dang, yeah. Okay, chapter 8 though. Let's finish here. Because I want you guys to make sure that you put these formulas on your half sheet. Because when you guys were working in your groups all together on the chapter 8 test, when you guys were working all together in your groups, some of you, your whole group got stuck. Why? Maybe you didn't know the formulas. And so if you can get them on a half sheet of paper, you'll be ready for these quadratic questions. Yeah? So I'm going to go ahead and pull up your Google Classroom first of all, and let's look at that summary page for chapter 8. Because I'm giving you these summary pages to help you out. In your Google Classroom, remember, you have all these different practice tests, and you have summary pages. So, chapter 8 summary page. There's good stuff in here, but let's see what's most important. Okay? Learning goals. What you're supposed to do. I mean, that's great, but I don't want to put that on a formula sheet for my final. That doesn't help. Trey, what's up, bud?
He's back there.
Yeah. Core vocabulary. I mean, vocabulary, the main vocabulary, it's good, but, Were some of you guys on the quiz asking me when is there a maximum and when is there a minimum? Remember that? Okay. So one thing as far as vocabulary that some of you guys might have gotten stuck on a little bit is min and max. I know the 5-minute bell is ringing today, guys. It's okay. So we have vocabulary. Min and max is pretty important. I'm going to get that up here. But do you also remember that I was asking things on these questions like what is the y-intercept? What is the vertex? What is the axis of symmetry? Now, on your final, do you necessarily want to have like memorized a paragraph of information in math? No, that's not helpful. But what is helpful? Well, I'm taking these things from the concepts page and I'm saying vertex. That is going to be an x and a y. It's going to be a point, and the x is going to come from the axis of symmetry x. These two are going to be shared. What one is, the other is. But to get this one, I need to go ahead and solve for, what's the formula? You guys remember? The formula that makes it so much easier. If you
Why
have
was that
any
supposed to be?
negative b all over 2a. And where does that come from? That comes from a basic quadratic where I can write a times x squared plus bx plus c. So if I plug in and I simplify, my axis of symmetry right there is just x equals. That's it. My vertex says take that x. Oh, what did you guys have to do on the quiz to finish the vertex? Once you have x,
A y.
how do you find y though?
You plug in 0.
Okay. Well, plugging in is for the y-intercept. I actually don't have that one up here. Let me write it up here. The y-intercept is 0, comma. I solve for the y by, anytime I have an x, I find the y by plugging in. I plug in. I plug into my function. I say, oh, I know x is 0. Plug it in, solve. Don't forget PEMDAS. So this one, even though it might not be 0, it might be something different because of my formula. I still, and a lot of your groups were doing this, you just got bogged down on the fraction one. But you can plug it in. So I have to go ahead and plug in x equals box and solve for y. Just reminding you of what you guys were doing on the quiz. You might have gotten bogged down a little bit. But technically, there is a way to do it in your calculator if you have a calculator you're going to use for the final. If you want to bring it in, I can show you how to plug it in without having to do all the crazy PEMDAS. When else did we plug it in? We plugged it in when we had to graph with a table. But we saw that you technically only need 3 points. If it's a super basic one, maybe -101 is enough. But if it's a harder one, you always want to put the vertex in the middle. You always want to put the vertex in the middle. If you have the y-intercept, you can put him in as well. But if not, then you're just going to do 1 point to the right of the vertex and 1 point to the left of the vertex, and then you will have your 1, 2, 3 to get your swoop. Or you'll have your 1, 2, 3 to get your swoop, if I can connect my points. But let's use these two different concavities to remind us of a couple things. We can have a concave up parabola, or we can have a concave down parabola. But do you guys remember what's going on in my equation that makes it go up or makes it go down? Which number do I look at to know whether it's facing up or facing down?
C.
Close. C is actually the guy who tells me where it shifts. This shows me if it's moved up or moved down. But what's the guy that tells me whether it's a happy one or whether it's a sad one? That's E. Keep going. Yeah. The A guy. The A guy, if A is positive, positive A, a positive. Remember leading coefficient? He's that guy in front?
Yeah.
Usually, however the leader is, kind of sets the tone for the whole thing. If the captain is really like down in the dumps and has given up on a game, usually the team is going to be like, well, that's great. But if the captain is the one who's pushing and saying, we can do this, then they're trying to bring up the team. Anyway, the leader usually sets the pace, sets the tone. So if A is positive, hey, there we go, concave up. And if A is negative, concave down. Now there's this whole max-min thing. Max-min, we have our vertex here and here. Minimum is going to be the lowest point. Maximum is going to be the highest point. Guys, what am I trying to do on this page? Give you some good things for your formula sheet. Give you some good things for your formula sheet. Pause! I said I would tell you how to get extra credit the day of the final. How do you get extra points on the final?
Cheat sheet.
We have done Chapter 7 practice test, right?
Yes.
And you were supposed to show work on paper. If you have Chapter 6 and 7 and 8 practice tests attempted, stapled together with your name on it in order, turned in, it'll be worth plus 5 points on your final. But not an A and a B and a C, like, oh, I just guessed letters, but actual work for Chapter 6 and 7 and 8 practice tests. I'm going to put an announcement in your Google Classroom. It's not the whole test, because they're the nasty word problems. I'm going to tell you what problems to do. But if you have 6 and 7 and 8, staple, name on it, and turn in on Monday. You get plus 5 on your final. I'll make an announcement in Google Classroom. Bye, guys.
Get that extra point.
Yeah.